We shall see in about an hour from now. I'll check who is sleeping next to the laptop.
No one is sleeping.
Nah, I won't let you sleep.
Ah, I don't sleep.
Uh,
You know me already. I don't
I,
sleep.
you, I know.
But no.
Yeah, I think we can start. Do you record this right now?
I think Emanuela, you're recording, right?
All right, awesome, awesome. Yeah, just so we know. All right, people, welcome to the session. It's damn 62 people. Um,
Nice.
and I'm really happy to show you this side of our business because rarely you hear people talking about what is the right platform for your systems, but you mostly hear, oh, Kubernetes is really nice. Yeah, it is, but let's go through our options to see what is actually the fit for whichever situation. So this is the goal for today's session. Um, More specifically, we're going to go through a very simple framework of how you can choose the right platform for your application and for your team. This framework is something that I have developed, and it's something that I have developed from the past years, about a decade of experience, and from learning from people around the world. One of them is Tarak, and other great people in the industry. Well, I have a privilege to call friends such as Tarak. So,
Yes.
a very small frame, very simple framework that's going to define the success or failure of the platform we're going to build. We're going to go through three examples of architectures and assess their cons, pros, the trade-offs of its decision, and at the end assess if this was a success or not, the platform that we are building. All right, let's get into it. So, as you know, as you of course hear all the time and read on LinkedIn, on blogs, whatever, most teams start with the questions like, should we use Kubernetes, serverless, Docker Swarm, or whatever that is, right? They go with tools, which is great. I get it. We are engineers and we use tools to solve problems. But in this situation, in our profession, it's a bit more tricky because the platform we're going to build is not supposed to be something that we maintain all the time. It's something we are supposed to build and hand over to developers so they can use and ship their products without us, in quotes, I'll say this, babysitting them. We are supposed to enable them, deliver more for the benefit of the business, because that's what it is at the end of the day. All of this is about the benefit of the business. So what would you use as a question inside of, hey, should we use Kubernetes, serverless, whatever, is what does the product need and what can the team support? Because when you start asking questions like, what does your product need? If it has huge traffic or slow traffic, and if your team is tech savvy regarding Kubernetes or not, is going to really define how you're gonna design your solution. So this is our very simple framework. I told you it's very simple. It's just three pillars, right? The needs of your application, that may be the traffic, the deployment strategies that you may need to use, and your team knowledge. Do they have any idea about serverless, about Kubernetes? If they do, then that's a tick. You can explore these options. If they have not, and you design a beautiful solution that looks good on paper and on our dashboards, and they cannot use it, then what's the point, right? And the very tricky part, maybe the most tricky of them all, is the total platform cost. And spoiler alert, it's not just the cloud bill of AWS or Azure, which at times is significantly high, but it's not just that. and we'll talk about this. It's one of my favorite things to talk about. So our application. If our application is, for example, heavy on loading traffic, I'm going to use an example. Netflix is, we all know Netflix. Yeah, it has a very heavy traffic for sure. Then this is one of the pillars we can assess on what platform we're going to choose. If our system has a relatively low traffic and a small container can do the job in a server with just Docker run, this is just an example that I'm using, then maybe this is the best solution. But the more you dig in, besides the load, the more you're gonna start finding answers to where is the best platform. As another great example is your deployment strategies. And most of the time, with Kubernetes, at least we use a default one. In other occasions, you copy paste configuration files in a server. In the old days, at least that's what we did. That's what I did in the past. And these topics will define in a great extent of if you're going to choose serverless or Kubernetes, because Kubernetes offers a lot of different things on how you can deploy your services, split the load, go very specific on your restrictions of networking and all of that stuff. But it all comes down to what do we actually need for our application. The second pillar, which is very interesting, it's about what the team can handle. And as I said, if our team is not, in quotes, I'll say it again, tech savvy with Kubernetes, with serverless, with whatever we choose to implement, and we design a great solution, but they cannot do anything on it, they cannot see the logs of the pods, for example, or they have no idea how to debug a container, then they will ping us all the time for it, and we will not be able to move on and build other systems or improve existing ones. So this is a very important metric, and I have seen this many times. I have joined teams with great engineering solutions, great platforms, but the team cannot use them. And I end up doing unofficial sessions with them where I try to educate them in these platforms. But yeah. So the spoiler alert, I told you about the overall cost. Yeah, the cloud cost is for sure can be significant. It is a metric most companies use, not most, all the companies use, and it makes total sense. But besides that, we need to assess how much time we're going to invest in designing and building and maintaining solutions. So a small implementation of just, for example, a serverless system, when you have like 5, 10, or 20 functions running inside a function app in Azure, for example, has almost zero maintenance cost. I know this because I work with a team like that, and I'll go through the example later on.
Yeah, that would be. Or can you please ask John to mute, please?
Sorry?
Can you kindly ask John to mute her mic, please? Because it's causing a lot of distractions here.
What did she say?
I'm not quite sure.
What did you say?
No, I was saying,
can you kindly ask Josh to mute his mic, please?
Ah, I think he's muted. Ah, okay, cool. Yeah. All right. I think we're good, right? Yeah, we're good. This silence.
Yes.
All
yes.
right. Moving on. Well, bottom line, as you can see, that time is money. That's what it is. Let's say a developer costs, for example, in European standards, 500 euros per day. Let's say a rough example, right? If a team of developers, 2, 3, or 5 developers, invest 35% of their time in debugging and maintaining a platform, then this is money that we need to add up along with the cloud cost. This is the overall cost of our platform. And this is something that most organizations have a really hard time to track because it is very difficult to track. And this is where it leads us to the main trade-offs. And if you really think about it, it's very simple. The more control you want to have, or you choose to have, flexibility and options, whatever, that means Kubernetes most of the times, you have insane control of what you can do, the higher the operation cost, the more time you need to invest in building, maintaining, and debugging. Most of the time, it's about debugging. We all know that, more or less. But the more you shift this, the operations time to the cloud provider, when you choose managed services like serverless or container solutions where you can just run your containers and forget about them, forget about the whole Kubernetes side, then sure, your cloud bill, you'll see a difference for sure because these things cost more in cloud systems, but you get time back and you can invest this in more features, in more platforms for the benefit of the business. There's nothing free, as I have wrote here. There's nothing free. It's just different trade-offs, and every time we try to build what makes sense for the application and the team and the business. So let's go through the first example, which is very, very simple. At a time, I was working with a company in Berlin, a very small startup, and their setup was 2 servers, load balancer in front of them for obvious reasons, because there were 2 servers, a database, and just one container running in the server with the Docker run command, not even Docker compose. Very simple setup. And it made sense for them because they were a team of 3 engineers, 2 software engineers and 1 data engineer. That was it. And they had no knowledge on how to update the servers, how to utilize other AWS services. The whole thing was on AWS. And for their situation, it made sense. It was a simple setup. Not the best one, but it made sense. They were able to ship features fast, and especially in a startup environment, this matters a lot. You need to ship features as fast as possible, get new clients, show it to investors, whatever. So yeah, and you don't want to depend on a consultant to join whenever she is available to support your cloud infrastructure. So the simplest they could get, that's what they did. Another interesting choice is the serverless. I'm working with a team right now in the company that I am, when they have a setup of serverless applications. And for their use case, it makes total sense. They need me almost 0% of the time. I just do the bare minimum of maintenance environment. So they're able to ship features very fast. And for their situation, because they are an event-driven application, it makes total sense. And here's the big boy, Kubernetes. And I have to admit, this is the very first thing that attracted me to this side of IT, or to the DevOps side. I really liked what you can do with it, but it's extremely, in quotes, dangerous when you implement it everywhere because of the cost that it has in maintenance. But it is a great solution when, for example, you have 2,000 services running. I was working with a company, they were running 2,000 services, a marketing company. Different deployment strategies, splitting traffic across services. It made sense for this occasion. Serverless for that would be too expensive, but Kubernetes, for this example, yeah, it worked like a charm. They needed control, and they had it. So let's go and compare these three models. Through the flow that I have given you hints of what is best for which situation, but let's go more clearly and compare them all three. The simple infrastructure of the startup, the serverless setup, and the Kubernetes one of the 2,000 services running. So the benefits of the simple infrastructure when you can use it, I gave you an example of just a team of 3 people of startups setup. Small team and very simple product, just one container running in a server with a Docker run, relatively slow traffic, manageable load for this setup. So yeah, in their situation, it made sense. They were deploying very fast their solution, and that's what mattered to them. They had a bit, as I say in the cons, a bit of maintenance in the servers, and if they wanted to scale up things, they would need to reach out to someone else. But for their setup, until they reached that level, they were really good with this one. So it made sense, a simple setup that worked for the situation. So the serverless one. As I told you, this is a great setup when you have an event-driven system. You want to have relatively zero operations. You don't want to depend on a DevOps, or let's call it operations person. Your traffic is not that huge. Yeah, in these situations, it makes sense. One of my developers is shipping code to the development environment through Visual Studio, not even using a CI/CD pipeline. Develop something, instantly it's on the function app. He can check immediately what he has built and ship it to UAT and the rest of the environments. So this is a scenario of a good platform that they need me almost 0% of the time, and I'm able to do other stuff. It has a little bit of trade-offs. Sure, yeah, you got very low maintenance, but the cloud costs can spike a lot if you have unpredictable traffic. Our big boy again. And the overall concept of it is that you have an amazing amount of choices of what you can do. If you want to split traffics, deployment strategies, whatever, you can really get crazy into that and design your platform if you have a lot of different needs per applications. Even host all of your applications of your company inside of it, not just for your team. You can do that. You're gonna invest a lot of time on it though. That's a trade-off on it. It's time and complexity. Kubernetes is a very big ecosystem, as I'm sure most of you know, or for sure have heard. It's not just a Kubernetes cluster, it's everything around it. CI/CD pipelines, Kyverno, Argo CD, the management of secrets, ingress controllers, whatever. I'm not going to go through them right now, but you get the idea. A lot of maintenance, not debugging, maintenance. Debugging is a whole another story, which is also time that you have on your hands. So we reach the question. Let's say we pick one of these solutions, right? The simple, the serverless, the Kubernetes one. This is a very on-point question to ask first yourself and then your developers probably. Can they operate it without your help? So can your developers take the platform, write their code, whatever they're developing, and ship features end-to-end without pinging you for a failed pipeline? The pod is not starting. The image is not there, whatever that is. Then you start to understand that if this was a success or not. It's very wide, but it's very specific in a way. At least that's how I understand it. Our job is to allow them to build, ship, without needing us, so we can go on and design other things, better solutions and platforms. Because if every team needs a DevOps, then guess what? We're not DevOps anymore. We're operations like in the old days. And I'm saying this from experience because I've been in operations for about 5 years before I transitioned to DevOps. And I was literally doing this. I was doing the deployments and upgrades and everything. So if this is the same scenario, the same silo, but with much more cool and advanced technology, then it is the same. It's operations again. We're not enabling developers. We are operations, and everyone is holding on to us to ship their features to production or whatever. So the framework is very, very simple. You draw 3 circles. I'm kidding, but I do draw circles when I have to make decisions. So whenever your application needs team knowledge and your total costs align, and this is the very center of it, this is what you use. That's how I perceive it. This is where everything comes together. It's not the cheapest, the newest, whatever. It's what works in our situation. And I know it's very difficult to talk with companies and be like, hey, we shouldn't be using Kubernetes anymore. We should use XYZ things, whatever that is. If you're thinking of this is a better solution, it's very difficult to talk them out of it. But if you have the chance to approach a new project, whatever that is, then this is a good framework to start with. Even if you take this framework and redesign it according to your knowledge, your needs, that's the main point of this. It's not just to give you something and follow it blindly. It's that it can spark your curiosity. But yeah, don't just go blindly implementing Kubernetes everywhere or monoliths or whatever. It's about the scenario that you have on your hands every time. That was literally it.
Thank you so much. I loved it.
Thank you.
Anyone, any questions?
I'm sure you have questions. Please don't tell me that 80 people don't have any questions and know everything. If you know everything, I'll go right now and, I don't know, have a paloma or something. I'm sure you have. Give them to me.
Don't be shy, eh?
And even if you cannot think of something right now to ask, which can happen, I myself need time to digest things. And after 1-2 hours, I have questions. You can send me on WhatsApp, on LinkedIn, whatever, and we can talk.
So, Pavos, I have a question related to security guidelines. So it's actually, first of all, really thank you for the great explanation. You have divided for the 3 phases, and which is the really great approach for all of that what you have actually shared here. The question is about the security. So you told that you have you leverage it as operations. So it's in my case this is the same. All what you have talked, I have actually felt the same scenarios, same the actions on my past projects. Okay, so in case of the security, what do you think about which of the best of these 3 scenarios that you can advise the security options there?
In the 3 architectures that we talked about.
Yes, exactly.
I'm gonna not say answer. I'm gonna approach this backwards.
Yes.
Let's pick this one, right? Let's say we try to implement security in this huge thing, which I love and hate at the same time. And a love for the control, the capabilities, hate for the complexity. Let's say you try to secure the whole thing of Kubernetes and manage one, not even the control plane. I'm not gonna go into the control plane.
But you see, You will advise some kind of the istio or some kind of the ingress
No,
topology.
no,
No,
it's
no.
not about the tool, Istio or whichever service mesh. No, no. It's that you need to think of it in every single level.
Mm-hmm.
That's the
Exactly.
issue. The pod, the container, the service accounts,
Exactly.
everything. You need to secure every single level. It's not just that I'm gonna throw a firewall in front of it, I'll be good. It's like a big castle with layers. That's how I perceive it. The previous days, I told my team that I found some containers, for example, that they were lacking security context. It was just not existent in some of them. So someone could have hacked into this container, take control over it with admin privileges, and go through the cluster and do whatever they want. And that's a problem. And that's just one small part of Kubernetes that you need to secure. So is there a perfect solution? Of course not, there's none. But the more complex your solution and the more capability it has, then the more things you need to think of to secure. That's the tricky part. With more power, you know what, it comes greater responsibility. We all know that. And the greater the security threats. That's why I am a very fan of pick the most simple thing that you can use because it will be much easier to secure also. I'm not sure if I answered your question, but for me, it's not about the tech. It's about I need to secure every single layer. All right,
Yes,
let me pick the
actually,
most.
those actually, I kind of waited this kind of the answer, because when someone is asking DevOps about the security, again the DevOps comes back to the start and starting to calculate and planning all the section, all the parts of the infrastructure. So why actually ask it if I am thinking the same way as you are thinking? So I have got my answer. Yeah, totally agree
I'm
with you.
glad.
Thank you for your answer and for the great
Thank
job.
you. Thank you very much.
Thank you. Guys, do you have any other questions?
Samuel has a question, I think.
Yeah, right. Go ahead.
Okay. Hi, Tarak and Jesus.
Hi.
My question is, when choosing a platform, do you choose based on the current needs or building for the anticipated scale and complexity in future? And
That's a great question.
will the traditional infrastructure limit innovation or growth? And which architecture aligns best with future business goals?
Yeah, that's a great question. I think I've talked about this with some of my colleagues and peers in the industry in general. And I have a friend who gets these questions all the time. He's a very senior consultant. It's basically he answers these questions all the time. Tarek, you know whom I talk with about Steve.
Yes.
Yeah. So business may want to implement XYZ features in about a year, 6 months. Let's say 6 months. We all know that 6 months may mean a year, 8 months, or never, or even 6 months. It happens. If you don't have a solid need to scale to do whatever you want, your application needs, we always go back to the first principle. What does your system need, your application? Well, when we think about we may need this in the future, it would be nice to have this capability. Yeah, that's when we introduce complexity without actually getting any money out of it. I'm okay with implementing, for example, Istio or whatever that is. But will I get any benefit out of it? That's how I I try to approach these conversations, because I have conversations like this in my job. We're designing an IDP right now, internal developer platform. They started with tools, and I was like, let's take a step back and design and think what we need to solve as problems. Fun fact, most of our IDP is already there with existing things that we have. That's how I approach it. Now, if the business is like, we want to implement Kubernetes because it looks good on paper, and I get it. When you approach customers and sell the AI and Kubernetes dream, they are intrigued. Makes sense. But who's going to support this? Let's say we implement it, and we will. It's about the support after the implementation. Implementation was never a problem, especially nowadays with AI. I'm not sure I answered your question. I think it's a very big matter and a very vague one. Did I?
Yeah, plainly you did.
I see a question in the chat from Collins. Hello, Collins. Company has 3 microservices, the call microservice and 2 event-based services. I'm smelling RabbitMQ and Redis here, which at some time need to run asynchronous or parallel. Okay. The total amount of traffic can be over 1K since they have outside brokers and on the move drivers, as well as direct clients that are moving load and more. A typical TMS system end-to-end. Will such a system require Kubernetes or serverless, event-specific? Why not both? Well, you can use both if it makes sense. But if it's just, let's say, 3 microservices, for 3 microservices, a Kubernetes implementation, I don't know. I will try to avoid it as much as I can, because for just 3 microservices, for just one Kubernetes environment, development, UAT and prod, that is, you need at least one full-time operations engineer. And I was one of these engineers in my previous role. One Kubernetes cluster per environment with 20-something services running. Most of the time I was maintaining and debugging. Most of the time. I had almost 0 time to do to implement new features. Or I was working overtime about that. I'll try to avoid Kubernetes in this situation, unless you already have it for other applications, so you have the setup all living right there, and you know how your way around, or your team does, then maybe. Again, maybe. And it depends. Do your developers know how to handle this, how to handle a Kubernetes scenario? My mind always goes back to these first pillars: the application needs, and what does your team know. And one thing that I forgot to mention, it was not in my notes, on the last pillar about your team knowledge, is that you can also share your knowledge. You can do workshops with the developers within the companies. I'm doing a workshop now in the company I worked at. It started very small, talking to 2 or 3 people. I raised the issue that, hey, my developers don't know anything about DevOps. They have 0 clue about pods and containers. You can always educate them. So if this is your problem in the architecture you're trying to build, it is solvable. Yeah, it really depends. It really depends. I know it's frustrating to hear that. I was frustrating to hear this when I started in IT. Everyone was telling me it depends, everything that I asked, but that is the truth.
But I think your second pillar approach is more answer of this question, answer the Collins question.
Maybe,
Yeah.
maybe. Yeah. But yeah, I'll say this again because I really believe in this. try to educate your developers if you see that there's room there, because some don't want to hear about it. They hear Kubernetes and want to go the other way or whatever, but some are curious. And if you start a few conversations, not official sessions or whatever, just start a few conversations, and you see that there is interest, you can raise the issue within your organization. Fun fact, I did this just out of curiosity, and the organization is planning a workshop that's gonna go across Europe. And I was like, I was planning for a few people to educate them. And they would tell me, yeah, half of Europe will watch this. I was like, okay, that's cool. We'll share knowledge, but yeah, no pressure, right? But yeah, I'm a very big believer and fan of sharing knowledge, if that's an option.
Samuel has another question. Yeah, Samuel, you can ask your question.
Yeah, go ahead.
Okay, you talked about the risks that are there when choosing a more complex infrastructure. So my question is, what are the risks when we are going for simplicity of a more complex infrastructure? Because I think there are some risks. Maybe will it be less competitive? Will the business be less competitive to other businesses that have a more complex infrastructure, or such risks? Can you just tell us about the risks that are there when you're going for simplicity of scalability?
Yeah. So I hear in my mind, I hear two risks: a business risk and then scalability risks. Am I right? Because we're talking about how, let's say, another rival company can have a more complex setup, whatever that is, and they will be able to sell this in their customers more. Because you sell the Kubernetes dream or the AI dream, agentic AI. That's even cooler now. And yeah, but in terms, this is a business issue, which is very interesting to talk about. We can do that for sure. I'm a very fan of it. But in terms of scalability, it really depends. I know it is frustrating to say this again and again, and I know, but it really is. If you have some metrics that indicate that your traffic is going to go huge, let's say in the next month or so, you're hosting the Super Bowl. I have seen a company doing that. They hosted the event of Super Bowl. So they needed to scale all of their systems. Yeah, then yeah, sure, it makes sense. Of course, it makes sense to do that. Go with a more complex system, but it's not the complex system per se. It's that you need more power to handle more traffic. It's not the scalability per se. And sometimes I have seen that engineers, some brilliant engineers, can do small changes and really handle much more traffic without implementing a nuclear rocket. I know the answers are very broad. I know you're right. It's frustrating, but unless we have, a specific scenario, then we can chat over coffee if you want. I'm happy to do that. For me, it's fun. Yeah, it's very vague of what we can do. Oh, George, yeah, I see a question in the chat. Deploying a platform from scratch, the role scope. Good question. You're doing network configuration, security, debugging, scalability to see how do you start. Well, you know, mm, you kind of do everything at once in a way. So when you start building a solution, let's say there is a Kubernetes one, the popular solution and the most used one. Um, I was implementing a feature, speaking of, with an example, yesterday. I was deploying a new application in a Kubernetes cluster from scratch. I had nothing, no pipelines, Kubernetes manifests, even I created the Docker file from scratch, following patterns, but from scratch. So how I approach this, let's talk about this example, is that I built the manifests and I implement security first thing. My first two issues, besides of how simple can this platform be, is how can someone hack it? How can someone get access into it? So how can I secure it? And how can I prevent observability in terms of know what's going on without firing a million alerts in the Teams channel? Very usual tactic. So yeah, I think we do all of them are in quotes are ones. The security, the observability, the everything when you build something. Some other questions have popped up. That's interesting. Let's get the juices flowing. So I see a question from Brian. Given Kenya's data protection requirements, how can organizations legally and securely use international cloud and AI services such as OpenAI or Google Cloud while ensuring that sensitive data remains within national borders? That's an interesting one because we have similar things in Europe right now. And yeah, I'm not sure this is the answer to your question, to this question, not just yours. But I think the problem here is about the data sovereignty. It remains within national borders. Yeah, that's a good question. I have to be honest, I don't have a straight answer, but I'm curious to look that up and we can talk about this. I can find you one chat and on WhatsApp and we can talk about this. Let me save this question because otherwise I'll forget it in 10 minutes. Okay, I got it. That's an interesting one. Got another one from Stephanie. For SMEs that don't have dedicated DevOps teams, which happens so often, that's true. What are the practical trade-offs between starting with serverless versus going straight to containerized solutions like Kubernetes? Yeah, why go straight into that if you don't have a dedicated DevOps team, though? That is the question. You get married with the complexity right after you start, which is great if you need it for sure. But if you don't have at least one person to handle one or two Kubernetes clusters in your deployments, you have to have very, very advanced software engineers who know their way around Kubernetes and pipelines and deployment strategies. And from my experience, I know only 3 people that are software engineers and are able to do DevOps tasks. Only 3 people across Europe, that is, because most developers don't want to mess with these things, and I don't blame them. So this is a nice example. If you don't have dedicated DevOps teams, I would very much suggest that you go with as much of a managed service as you can. I understand you may have containers, sure. You can use, for example, from Azure, the Azure container applications. You just host the containers right there, and that is it. You don't need to get the AKS service or similar like that. Or with AWS, I think it's called Elastic Container Service, ECS. It's not the Kubernetes one, it's the container service. I would go with that one in this scenario. Samuel, I see your hand is raised.
Yes, yes. You had said that when a platform is built and it needs DevOps, it's built for dependencies. So my question is the goal of the platform engineering to eliminate the DevOps dependency, or to create a platform where the engineering reduces the load for the developers? Which is the best way to go, to eliminate the DevOps dependency completely, or to reduce the load for the developers?
So what's the best way to approach the platform engineering? Is this the question? Am I understanding it right?
Yes, yes, yes.
Well, I'll give you an example. I work better with examples. A good example at a bad one. What to do and what not to do. I work with a team, as I told you guys in the presentation, that they use a serverless setup. They are a team of 5 engineers, 5 developers, and I even taught them how to go inside the Terraform file that holds the environment variables, edit it, push it to Git, and the automatic pipeline executes Terraform itself. So they can do everything by themselves. That is a platform. Personally, I do not care if the system has an IDP in the front. The IDP is not the point. It looks very cool for sure. But what matters is, do the developers need me every day or not? Can they ship from dev environment to UAT to test and with a small approval to prod without my intervention? Can they debug the systems themselves? And my team can do that. I taught them how to do that at some points, and now I am free to go do other stuff. For example, I'm working in a cloud migration, which is another topic. It's not very DevOps related to the platform. It's purely cloud engineering, but whatever, it's cool though. But yeah, this is a good example of a platform. A bad example is that I work with a team where they have just one container, just one deployed in Kubernetes. It makes no sense. It's not that they need the scalability, the different deployment strategies, split traffic, whatever, the cool stuff of Kubernetes. Someone came and said, we have other applications in Kubernetes, we also deploy that there. It makes sense. We'll have everything in a central place. From that perspective, I get it, but my team pings me all the time for things that it needs. New secrets, environment variables, deploy a new service, whatever. This is a bad example because they need me all the time. And they need me for trivial stuff. It's not that we're doing something, whatever, very big, very interesting, that's gonna bring revenue to the organization, whatever that is. It's for small stuff. So I'm not able to grow, and they need to keep opening tickets to get to me. So that's a bad example. It's the same team that I'm educating right now, so we can reduce these types of tickets. Fun fact. Or we have unofficial DevOps sessions. And even the QA engineer now knows what the pod is, what the container is, and what Argo CD is. So kudos to them, because they're smart people. But yeah, this is a bad example.
Okay, thank you.
Thank you. Thank you for all the great questions. Something from Collins. Hi, Collins. I'm a software engineer, but I'm finding DevOps very interesting. It is. Let me tell you, I am moving forward to make it more like play for me. So you're in for the trip. Okay. You know, the very interesting thing from people moving from software engineering to DevOps is that you already know the pain points. you know how painful it is for a software engineer to wait a DevOps team to provision something in the cloud, small change in Kubernetes, whatever. You know the pain points. So it will be a good fit. If you're fascinated about containers and pods and stuff like that, and CI/CD pipelines, which is practically scripts running in literally a pipeline. If you're fascinated by that, go ahead. You're gonna have a lot of fun, a lot of headaches also, but yeah, the pros and cons of every situation.
And I think we have another question, and after we can take a picture and we will be done for this great session. I think from Stephanie.
Yeah, Stephanie and Masango.
Yeah, if you can read it.
Yeah, of course. So from Stephanie, at what point does a system outgrow serverless? I like this one. And justify the complexity of Kubernetes, and especially in low resource environments. You have me right there, Stephanie. That's a nice question. I'm not sure why I get so excited about that stuff, but I like it. I guess the answer is control. It's not about always the low resource or the high resource utilization. That Kubernetes is really good at scaling in and out, vertically, horizontally, whatever, or based on events. It is about control, because you can be very specific on how you do your deployments. If your business, whatever that is, let's say a banking business, does not allow you any downtime at all, then you can use different deployment strategies from Kubernetes. I think there are 8 of them, if I'm not mistaken, a lot anyway. So you can satisfy your needs on that. Or if you want to split traffic, for example, maybe the traffic is not that huge, but maybe you want to split traffic at times. You can do that. Maybe you want to modify the requests before they reach your service. You can do that with Ingress, and it's really cool and weird, but also really cool. It's about control. That's how I would think about it. Yeah, when you outgrow the serverless ecosystem, because you have very limited control in a serverless ecosystem, and it's meant to be like that. Did I answer your question, Stephanie?
I think so.
I think I did. We have got one more with Masango. Masango, go ahead.
Greetings, thank you so much. I just want to confirm about the attendance register because we are still waiting. Are we going to mark it or not?
What is the so we are not at school, huh? So there is no, I'm not a teacher, and Fevas is not a teacher either. What do you call the attendance?
No, we usually get a link to fill in.
Okay.
As a register, just to show that you attended the class. So it's a Google form.
Yeah, you will not have it from our community. We are not at school. We're professional. If you want to join, you join. You're welcome to join anytime. If you don't want to join, you don't join. I'm not going to count how many people joined today. To be honest, I think it was a great session. But yes, if you want to join, you join. If you don't want, you don't join. Like for me, it's like life is not waiting for you. If you want to join, you're always welcome. But there is no attendance, there is no list, there is no, like, I didn't build a school, huh? So I know I built a university.
Instead of the attendance link, there is a link to join our WhatsApp group. So if you're really looking for a link, so find that link and join our WhatsApp group.
I shared it already in the messages. So 1 minute, we can take a small picture, extend the call because I think it will be done. Wow, I think we're going to be done now.